Hello, everyone, and welcome back. I can see we're all excited here. So I know everyone's been watching a lot of presentations. We've had a lot of fantastic content here today. This is going to be a little bit different. This is not a prepared presentation. We don't have a bunch of content and slides to go through. So I want everyone that's watching to just take a deep breath for a second. We'll do it together. All right, I think we're ready now. We're doing something new that we have never done before, or at least I've never seen before, which is taking the concept of video game speedrunning and bring it into the development world with smart contract speedrunning. And so we have two engineers here. Everyone, I think, has met Austin Griffith from earlier in the day. If you want to say hi.
Hey, everybody.
And then we also have Peter from Aave, who did not speak yet earlier today. Do you want to give yourself a brief introduction, Peter?
Yeah, hey guys, I'm Peter, also known as Zero Dot on Twitter, whatever. And I'm pretty much a dropout that thought DeFi was cool and something, somehow I just joined Aave miraculously. And here we are.
I'm going to get dunked on
Awesome.
so hard. I can
No way. No way.
All right.
Absolutely
So
not.
how this is going to work is in 60 seconds or so, I'm going to reveal a smart contract developer task or challenge. I'll give some parameters, and then it will be up to these two contestants to go. And the first one to complete the challenge wins. Although my hope here is honestly that everyone is a winner, both the participants as well as everyone at home watching, because I really do see this as like, if we can watch people that are great at their craft, we can all learn something, we can all do better. And so if this does end up taking too long, we've got two challenges scheduled and planned, but if it does take too long, I'll end up calling a winner. And then we should be having a little bit of conversation as we go. I'll be asking questions like, Peter, why'd you do that? Why are you rebooting your machine right now? That's not a good idea. Those sorts of things. So I think our competitors are all warmed up and ready to go. Hopefully the concept makes sense. Again, I'm going to reveal a challenge, and then the two competitors are just going to show their full process of actually implementing and doing the challenge in front of you. And we're all going to learn from that. We're going to see who can do it the fastest and what tools they use, all those sorts of things. Perfect. All right. With that, I am ready to reveal the first challenge. Contestants, are you ready?
Yeah.
Oh, yeah.
All right. If we want to share both of their screens, and then we can kind of watch them as they think about the problem. So I'm calling this any percent ERC20. So your first challenge is ship an ERC20 coin called SmartCon coin with 1,000 tokens and 18 decimals.
You get started?
Yeah, go.
All right, let's go.
Okay. Dope. Yeah, I'm just going to go to the Open Zeppelin website and copy and paste their stuff for that. Straight up right here. Where do you want
Let me know
us
if
to
my
ship
keyboard's too loud.
Your keyboard is very loud, but maybe it's just adding to the excitement here.
Where do we ship the token to? Where do you want it deployed?
I can paste an address. I can paste my address if you want me to.
No. I mean, what net? Do you want it deployed to mainnet, or do you want it deployed to a test net?
No. You definitely don't need to deploy to mainnet. Let's deploy to Coven.
Okay. Coven it is. Let's do it.
What's the name of it again?
All right. SmartCon coin. So I think we've got, Peter, you are on the right with the remix, diving right into remix.
Yes.
And I'll restate the rules. So you can use any code, any tools you want. This is any percent. Whatever is the easiest way for you to ship a ERC20 token on the internet, on the Coven testnet.
And the initial supply is 1,000, you said?
1,000 with 18 decimals. Looks like both of the competitors are choosing the Open Zeppelin route. In some of the practice runs, we were anticipating people using Brownie and some of the pre-written code examples.
Ooh, what did I do?
I got to say, watching Austin is a little disorienting because he flips between one screen and another.
Yeah, sorry. I'm moving from screen to screen here, trying to get the right.
It's part of the process.
Yeah, for sure. So there's the whole contract. It's just getting it compiled and shipped.
I think I'm done.
Is it deployed?
Yeah, on Coven.
I think
Peter,
I'm right behind you too. Yeah. There goes mine.
Peter won it. That was a very close race.
It was a good one.
Did you end up both importing from the same Open Zeppelin contract? It looks like. Do you want to zoom in on your code, Peter? It's a little bit hard to read.
Oh, sure.
Oops. Now mine's gone. What did I do?
I love Remix.
And Austin, what tool did you end up using to write the contract?
I'm using just like Atom, like a local IDE. Could be anything, VS Code. But I'm using Scaffold.
And then are you compiling and deploying it via Scaffold?
With Hard Hat inside of Scaffold. Yep, exactly. Yep.
Awesome.
And here's our address if we wanted it.
Perfect. Well, Peter, you've won this one. So this was the warm-up challenge. The next challenge is a slight bit harder. All right, challengers, do you want to reset or do anything you need to do, or are you ready for the next challenge?
Let's do it.
Challenge. Yeah, let's go.
All right. The next challenge is a little bit harder, and I'm calling it any % reactive NFT. So what you need to do is you need to implement an NFT, like following the ERC 721 spec. But this NFT has a special property. There is a contract out there on Coven, and I will paste the link here. This is a counter contract, and you should be watching this contract because it updates about every 2 minutes. And so what you should be doing is I want you to be updating your storage to include a copy of the counter every 2 minutes. So this is the idea that you're building a reactive NFT that stays up to date based on changes in another contract. And so there may be lots of ways to this. I would probably recommend you use like a Chainlink keeper to do this, but it's not a hard requirement. So again, you can't just implement like a view function that reflects the balance on that contract. You actually have to update your storage.
Okay.
So that's like a double keeper. Like you guys are running a keeper to one contract, and then we need to run a keeper on our NFT that stays updated with your keeper contract. Is that right? Make sure I understand that correctly.
Yes, that's correct.
Dope. Okay. One thing, and I'm totally a boomer here. I can't figure out how to copy. Look, I don't know if you can see this chat.
Yeah.
I can't copy the chat. Could you send that in some other channel? Someone just send me that contract address in some other channel. That 9.
You can send it on that.
I can't copy from the Zoom UI,
on the
which
summit
is some serious garbage.
Let me. I tweeted it. How's that?
That'll work. Let's see.
What's your Twitter?
Yeah. What's your? This is funny that like getting the contract address is the hardest part.
Okay, got it.
I think
you got it.
It's a super simple contract. It just says it's got a property that's called counter.
Okay, public property called counter. Sounds good. Let's do it.
Okay.
All right, let's go then.
You want me to mute my mic while I type?
Unless you want to share your excitement with the world.
People deserve my excitement. Let's keep it on.
The counter, are you at 256? I could probably go find that out. Let me just go find it. Is it verified on Covan?
It is not verified.
Oh, boo.
Would it be helpful if I provide an ABI?
I mean, it's fine. Just tell me, it's just counter? Like there's a thing called counter?
Yeah, it's a public, let's see here. It's a public uint. So default, I think uint defaults to 256. So it's uint public counter.
Got it.
Let me go look at the docs.chain.link. We need this. I think. Yeah, so this is really cool. I love Chainlink keepers.
I just checked it out yesterday because I got the hint that we needed to look at keepers. Yep. So we need to bring in the keeper code, we need to check in, and we need to get your counter and update our counter, but also have an NFT that gets deployed. Is that right?
Yes, it is.
Okay.
You're supposed to deploy an NFT contract that has this property.
Every 2 minutes, right?
It updates every 2 minutes, but theoretically it could update. You're just following it to make sure that to know when it updates.
Gotta fix my formatting.
Installing the Chainlink contracts now.
So Peter's in Remix implementing the spec for a keeper maintainable contract or a keeper compatible contract.
Just gonna grab all this.
Let's see what the chat's saying about this.
Okay.
Tippy asked us to remind the audience what we're watching. So we are right now watching a competition live between Peter from Aave and Austin Griffith, who presented today on Scaffold ETH. And they are competing to see who can build and ship a reactive NFT. So reactive NFT is defined as an NFT that is keeps its storage in sync with another contract.
And hold on, let me make sure I said that. So you're going to call back with the keeper, and when the keeper checks in with me, I want to mint an NFT at the current count, or I just want to keep a count up to date within my NFT contract.
Just you can keep an instance. I'll keep an NFT instance. You don't need to mint it each time.
Okay. And it's the token URI, or it's just a count that's part of the NFT? Like, what is the structure? Does the count need to be inside the NFT, or it's just in the NFT contract?
That's up to you.
Okay, cool.
So we've got some nice comments. Love it, woo woo, tech. Speedrun NFT development. Anthony has shipped a smart contract that's a betting pool on who's going to win, powered by Chainlink Oracle. But not really. I just made that up.
I would bet on Austin any day.
No. Like, really, like what I do is like build the whole app, right? By the time I'm done with this, I can deploy this to production and people can get in and mint their NFTs in a front end. Doing it in Remix is kind of like a secret move.
So it looks like both of our challengers have a perform upkeep signature from the keeper contract and a check upkeep signature from the keeper contract. And they are both extending the ERC 721 spec, looks like. And again, they're following the same pattern where they're just using, relying on the Open Zeppelin public contract libraries in order to ship that as an NFT.
So when I perform my update, I want to go out to your counter and get the value and store it in my contract. And then my contract needs to be an NFT contract.
That makes sense, right?
so
We have to
yes.
call your contract? Yeah.
You have to read the counter value of that contract.
Which I think
There is no.
Yeah.
Okay. So
So I'll leave some commentary because it's actually interesting. There's a few ways of doing this, and the challenge does not specify what you do. You could theoretically, in your perform upkeep, go do another lookup on chain of what the value is and assign it locally. Keepers also allows this sort of off-chain computation. And so you could, in your check upkeep method where you figure out whether or not you need to do anything, you could actually figure out, okay, I need to do something, and then pass that in as the perform data to your perform upkeep. And so you could theoretically, like, let's imagine we're not just doing a simple counter, we're doing something complex. You could do a bunch of the work off chain in the keeper by the check upkeep method, and then just consume that and validate that in the perform upkeep method. But it's totally valid to just copy it in the perform upkeep method as well. But the important thing to know about keepers is the check upkeep actually runs off chain. It's simulated by a keeper node, and then perform upkeep is the piece that's performed on chain.
Is that it? Does that work?
Cool.
Did I do something wrong? Let's try it. Oops.
So Austin may have just introduced no, he's using the timestamp. Interesting. I was expecting folks to use the, actually check the value against the current value, but timestamps work just well, just as well.
Let's try this.
So right now, both of the competitors are working on building they've already, I mean, the NFT code is virtually trivial. Now they're just implementing the keeper compatible methods, the keeper interface, so that they can go and register and upkeep. Maximilian in the chat says, awesome coding challenge is done quick with donations and comments in the input data. Maybe next time we should do that. We should do donations to support some sort of good cause.
It took me forever to get my contract to compile, as usual.
Oh, Peter is trying to register his upkeep, it looks like.
Oh man, he's ahead of me. I'm just now registering I'm just now deploying my contract, so he's going to be just ahead of me in the UI. That turkey.
Waiting to receive confirmation.
Here we go.
Upkeep registration request submitted successfully.
Gonna work.
He's gonna be.
Let's take a quick look at your code, Peter.
I gave it too much.
You already funded it with.
What's the
link,
front end? I'm sorry, Chainlink. Where do I register my keeper?
Keepers.chain.link.
There we go.
So here's it's confirming. Here's the code.
So you're checking.
Is the zoom level all right?
Check. And you're using the timestamp. And so you're just keeping a local copy of the timestamp.
Yeah. Okay, let me just go over here. Okay.
All right, and it looks like Peter might have finished it,
Not me,
although Austin is just right behind.
We don't know.
Close.
I am close, but here, you want to see? Okay, so now we're waiting for the confirmation here. Here's my code. Let's see, where is it?
So Peter, show me what your the counter value is on your contract.
Sure. So it just got called. At least it should have just been called. Right now it gave me 0. The upkeep was performed. The counter contract is this. This is a problem.
Because what I'm seeing on the public counter contract is that the counter is now at 3.
Oh, okay. No, it is 3. All right. No, we're good. It just wasn't updated.
Oh no, now it's 4. It was just
what? Good work.
Well, now we got to wait for the cooldown. Yeah, unfortunately, but yeah, there it is. It seems. I think I got it to work pretty quickly.
So Peter, you've got it all working. Austin, how's it going?
Looks like it.
We're about to see the app. I'm not sure. Let's see what it looks like here.
Do you want to zoom in? Those errors are a little bit hard to see.
Oh, me?
Looks like you've
no,
got
those are warnings.
scary.
Sorry, that was a mnemonic warning. It's all good. So the contract is here, and hopefully it was registered successfully. Oh, wait, shouldn't it take me to another page? Oh, no.
Did you complete the process? I'm not sure.
App is here, and my counter is at 4 right now. Yeah, so my counter is working, and it's at 4. So something is working.
All right.
Let's wait a little bit and see if the counter goes to 5.
No, if you, I mean, if it's at 4, then it definitely worked. So
Okay, cool.
Awesome job to both competitors. We've actually got a request from the chat that the code is very, very difficult to read. So maybe I can make 2 requests of you. So number 1, zoom way in on your code, like make it fill your entire screen, and then kind of slowly scroll through it so folks can see.
Yeah, both of us.
Even bigger, Austin. Get rid of the sidebar.
Okay.
Full screen.
The whole thing. Okay. Let's see. I mean,
and then you too, Peter, if you can make it a little bit bigger.
Get it to fit.
Sure. Is this big enough? Or you guys want me to go?
That's okay.
Even bigger. I think this
you could go even bigger, Peter.
We're getting rid of the import, but
awesome. I am delighted and amazed that both of you finished that so quickly. We had expected it to
my
take
butt.
longer.
No, I didn't. Not at all. No, it's not me. It's Remix. Remix is just so fast.
With 2 more commands, I can put this out at a URL, and anyone can get in and mint these NFTs and have a front end. So a little bit different tooling. Mine is for like prototyping for users. You were just getting the contract out, which is the goal. Yeah. You win. It was good. It was a great job.
No, we both win. I think that was awesome. That was a lot of fun. Yeah. And
awesome.
Hopefully,
well, I'm gonna have.
Yeah, go ahead.
Oh, go ahead.
I was just gonna say, hopefully people got to see a little bit that, like, it's actually not as hard as it sounds, right? Like Solidity is inherently like pretty simple and stuff like that. This is an NFT, right? The whole craze with NFTs, this is it.
Yep. Can both of you commit to uploading that to GitHub and then telling me your GitHub username so we can find those later?
Yeah, sure.
Austin, what's your GitHub username?
I'm Austin T. Griffith. It's a little tricky. Yeah, if you just go to Scaffold ETH, this will be a branch of Scaffold ETH. Go to Scaffold ETH and type in Keeper. You'll find this branch. It's actually already there.
Awesome. And then Peter, what's your username on GitHub so people?
Mine's my alias 0 capital ZER 0 DOT. That's my GitHub username, and same with Twitter. But with Twitter, I have an S at the end.
Do you want to type that so that?
Yeah. So I'll type it in the Zoom and in the chat. There.
See, and both of you are going to become millionaires selling these NFTs, I think.
Let's do it. Let me check. I wonder if it was updated yet.
I'm at 5 now. Yeah, it's updating.
It is. Wow. That's cool. I don't know.
Yeah.
Right? Yeah.
It's
this is a big deal. Yeah. See how fast it is? Like, that's great. I don't know. It's crazy. Like keep your architecture is actually really important, I think, especially in DeFi. I'm happy to see that we've got the infrastructure to make it super easy.
Yeah, we got the infrastructure and you were both able to do it within 15 minutes. So, all right. Well, with that,
time to spare.
Peter, you won both of the challenges, but I think both of you are definitely winners. And it was a lot of fun watching each of you take your different routes and the things that you shared. Like that, I think the fact that both of you relied on Open Zeppelin so heavily is just a huge kudos to that team. And that if developers are not out there using Open Zeppelin and relying on them, it's a much faster way to do things.
Can I jump in? I want to send my token number 7 in my NFT contract on Kovan. I'm going to send to Vitalik.eth and transfer that. Oh, I don't have any funds. Dang it. Okay, I need to.
you need Kovan ETH? I can.
No, I got it. I'll send it in.
Oh, cute. All right. Unfortunately, my NFT can't be minted. Anyways.
Oh, what? Your NFT can't be minted?
Yeah, there's no external minting. It's an NFT, but it just has a supply of 0.
Okay.
Okay, now I'm going to send my NFT to Vitalik. Here we go. Click. There we go. We get a nice update. And this UI right here, I'm currently building with one more command that this UI could be at a URL and anyone can get in here and I can send them around some of these NFTs. So like different approaches here for sure.
That is awesome. That is awesome.
Who wants the next one?
I'm gonna end.
Got an ENS address?
0.eth.
Yeah. So if someone wants to post an ENS address in the chat, you'll get an Austin NFT from the competition. First address I see in chat, I'm sending this zebra to on Kovan. First address in the chat. Thank you for having us. Sorry I interrupted you, Stephen. Thank you so much for having us. This is so much fun.
Yeah.
All right, we got proof of workout.eth.
Proof of workout.
Proof dash of
Got it,
dash
brother.
workout.
Here it comes. Boom. Congratulations, proof of workout.eth.
I love reading all these ENS names.
There it goes.
Awesome. All right, we're gonna close the speedrun. Should we do this again someday?
Oh, I'd love to.
Oh yeah, this was awesome.
Okay.
All right.
All right. We'll definitely do this again.